IF Live. Thanks for joining my session, The Future of Data and AI. My name is Joel Fensel, and I'm part of the database product management team. Now let's jump right in. We got a lot to cover. Let me start with our mission statement for Oracle Database, which is to make modern apps and analytics easy to develop, run, and leverage AI for any use case and at any scale. That's really what we have been working hard all these years in Oracle, and of course lately with the change in the industry to AI, we're now also working hard to help our customers to leverage AI inside the Oracle Database, again, for any use case and at any scale. Now, we accomplish this via a complete and simple platform for all data management needs. That is one, via a converged database architecture that is complete and supports all modern data types, workloads, and development styles, and simple in the way that rather than adding another database for a particular workload, we add another SQL statement or SQL statements to the Oracle Database to support the requirements of modern applications. And this keynote here is all about that, how we provide this complete and simple architecture. Of course, also, the best platform to run Oracle Database is on the Autonomous Database, our cloud service offering, which is an end-to-end automated across the entire database lifecycle cloud service and cloud native, because it's a cloud service, empowering organizations to build and run scalable apps in modern dynamic environments. So those are really the key messages that we have pushed in the last couple of years. Converged database architecture, we're calling it converged because we're bringing these different capabilities into the database, into one database rather than having multiple, and autonomous by allowing you to have this cloud native, self-driving, self-managing deployment methodology if you want that. Now, when you compare those strategies, just said converged is actually, we base our capabilities a lot on open standards, believe it or not, right? So we, for example, have the SQL standard, but also property graph queries as a standard. Everything that we add to the Oracle Database, when there is a standard, we adhere to that standard or actually push the standard in there so that developers and IT can focus on innovation. Now, there is another thought train or way of thinking out there, which is to use what we call single-use or single-purpose proprietary databases. So this is the thinking of like best tool for the job. So if I need a document database, if I have a document use case, I use a document database. If I have a graph use case, I use a graph database, and so forth. And that really we have seen for our customers leads much more developers and IT focusing on integration between those different databases or data silos rather than actually on innovating and delivering value to their businesses or to their customers. Now, the next generation converged database is Oracle Database 23 AI. So Oracle Database 23 AI just went GA on May 2nd, about a week ago. On Oracle Cloud first, and we got it out there for Oracle Database free and will be coming for on-premise very shortly. It's the same methodology that we have been following the last couple of years. We release it first on cloud, so you can actually start deploying it there if you want, or even just start with your new development environments there. And then a couple of months later, you will find it on premises. Now, the converged database architecture or this converged database approach has delivered incredible value to the businesses. There's actually probably also many of you out there that have upgraded an Oracle database to just leverage the new capability added to the Oracle database rather than actually bringing a new technology in-house, having to set it up, having to train the staff to know how to deal with this new technology, and. It's just the ramp-up time is much, much shorter because, as we will see later on, it's just another feature of the Oracle database. However, further advances in the industries continue to push the boundaries of data management, right? Again, I've said it before, AI kind of surprised a lot of us last year, right? It's like it's now called 23 AI, no longer 23C. Well, guess what we have been working on the last 9 months, right? Everybody is focusing heavily on these AI use cases. And hence, we at Oracle also introduced in Oracle Database revolutionary technologies to further unify data management at a more fundamental level. So what does that mean? Let's take a step back, right? Years ago, when I was still not born, and probably many of you also not, relational databases came out, right? And they had one mission in mind, to ensure data consistency and enable declarative access to any data via SQL, which is a declarative language, right? Was simple data organization, powerful declarative language SQL, which actually just turned 50, believe it or not. And 74 was when the paper for SQL came out. So SQL, the first paper on it, just turned 50 years old. And optimization is transparent to the app, right? So you have the cost-based optimizers and so forth that optimize your SQL statements. Then JSON databases were introduced with the mission to make data management simple for application development. Right, these JSON documents map easily to application objects in your application code or in your application runtimes, but they force now a choice between the simplicity of JSON documents over the power of relational, and I'll come back to that. We've also seen the emerge of graph databases. Their mission was to make it simple to navigate connections between data, right? So graph queries or graphs are really, really good to query across social networks, supply chains, sequences of events, basically find out how the data is connected or how a particular data point is exposed in the greater picture. But again, graph databases now force the choice between simple graph queries versus the power of relational. And then lately, we see now, same thing happening again with vector databases. There's a lot of vector databases out there, right? And their mission is to use AI to search based on the semantic content, right? Now, really what's happening here is like the worlds of data and app dev have further fractured, right? It's like, again, it's like the more databases you have, the more data silos you have, et cetera, et cetera. And what somebody cannot do today very easily in such an approach is to search data using a combination with SQL, JSON documents, perhaps a graph query, and AI vector search, perhaps, because all of these different formats or types of data live in different databases. So that is actually usually then done, or has to be done at the app level, regardless whether you kind of use a microservices approach, where each microservice fulfills a particular key concept or a key business area, or like a monolithic approach where you basically read the data from those different databases into one application. That integration between these different data types or formats has to happen in the application space, which is really great for developers because it means we get a lot of toys to play with and to get a lot of code to write, but it actually doesn't help us so much to stay competitive and get to market fast. Now, we are introducing revolutionary technologies that unify these worlds, eliminating the need for limited and costly fragmented solutions, right? With the unification of JSON and relational, the unification of graph and relational, and last but not least, the unification of AI and databases. And so this is basically, we now go step by step over those three areas of what's changing or what has changed with Oracle Database and what that enables us to do. Unification of JSON and relational, right? The simplicity of JSON with the power of relational. That's really what developers want, right? You want to be able to just deal with data in JSON format. They're very accustomed to this with REST calls and so forth. But there is actually inherent benefits in the relational model. So let's take a look. Let's envision we building a student schedule app. Yeah, we're all back in college. We want to know on Monday morning, hey, where do we actually have to go? At least I always wondered myself that. And we would like to have an app, right, that tells us, okay, these are your courses in the day. These are the classrooms where you have to go in the day. Now, such an app is actually really, really easily written if you were to use a JSON document approach, right? So it's like basically each student's schedule is just a single JSON document that holds the information for that student, right? And that's basically really the simplest form or one of the simplest forms of development if you were to write that application. The whole data set is self-contained in this nice little JSON document structure. And then usually, we use put and get REST calls to write the document back to the database or retrieve it from the database, right? So it makes it really, really simple for us in the application space to just absorb the data or generate the data and actually send it over the wire to store it or retrieve it. Now, however, there are downsides, so there's an inherent downside to storing data as JSON documents. And the document storage model really inherently suffers from data consistency issues. So why is that? Well, because data is repeated, right? It's like, so for example, all students taking the same course have a copy of the course information, as you see there on the slide, right? It's like, this is literally another copy of the course. So guess what's happening? If that course information needs to change for whatever reason, the teacher needs to go somewhere else or whatever, you have to touch each individual JSON document now and update that information, right? And that's the kind of data management 101 consistency rule is like, Don't duplicate your data, because otherwise you have inconsistent data very shortly after that. JSON also creates severe issues if you have multiple use cases, right, from a data perspective, right? So it's like, just like this, the students need to know where they should show up, also the teachers need to know where they need to show up. So if you create the same schedule for the teacher in the same paradigm using JSON documents, you will end up creating another JSON document where rather than putting the student as the root element, you will put now the teacher as the root element, right? And then basically, again, duplicate some data from the course information and so forth. Now, if you again take the same example of, let's say, the classroom just changed, we have to go now somewhere else. Now you need to update many student documents, right? Every student that is supposed to go to the classroom for a particular course, and many teacher documents or schedules as well, right? As where they had to show up, right? So now you're already in an interesting scenario where to update this atomically, what are you gonna do, right? How do you make sure that the data actually is consistent so that you can push out this update atomically throughout all the documents that you have? This could be hundreds or thousands of students. This could be a bunch of different teachers, right? Affected, given that the classroom obviously has different sessions. So there are these downsides in general with the hierarchical formats. This is not necessarily something particularly new to JSON. You would also have that in XML because inherently data is duplicated. Now, storing data in normalized relational format enables this consistency in declarative SQL, right, or declarative language, right? So in a relational model, you would obviously split up the data into different tables, right, and then store the information only once. You follow the normal form or something like that, and then these normalized rows are the single source of truth for the data that they store. No data duplication, hence no data inconsistency issues. However, relational apps need to join multiple tables to retrieve the student schedules now, or teacher schedules, right? And so to construct this application object in the application, these applications need to run a query that joins multiple tables, and that is usually known as ORM mapping. And that is basically more or less overhead for the application developer. They now need to reconstruct the object they actually want out of that normalized form. So it's great for data consistency, not so great for the developers. And here's where the revolution comes in. JSON relational duality, which is a new capability that we have introduced in 23 AI that eliminates these trade-offs. It delivers the simplicity of JSON for developers with the power of relational data. So how do we do that? Well, the data is stored as rows in relational tables that provide consistency and declarative query benefits and so forth. So the data is still laid out in relational form. And yes, the relational tables could also include a JSON data type column, of course, if you had some flex field use cases or something like that. But in general, the data is laid out in relational form. And then we have this new JSON duality view database objects that you create on top of the data that essentially define the mirrored structure of the JSON document. So you create this JSON duality view. You can use GraphQL if you like. You can use SQL JSON if you like. There's a couple of different languages that we support. Again, we adhere to standards where we find standards to define these views. And then in those views, you simply specify the tables that contain the data that you want to include in the JSON document. Here again in GraphQL syntax. And you specify the table columns that hold the values of the attributes in the JSON document that you want to expose. Now, once you have that, you can now speak to this JSON duality view via JSON documents to the database. So you can query then simply using a document-based API. So you get a REST GET call, or you could use our MongoDB API that we have, or you could still use SQL. But if you wanted to stay in this document API world, you would issue a REST GET call to this JSON duality view, as you see down there in the slide. And that will be sent to the database. The database will know it's a duality view. It will know how those tables are, or the data is constructed from those relational tables, and gives you JSON document back. So that is so well and good. You could do this actually for quite a few years now already with SQL JSON. But you can also now update these duality views. And this is where quite some power comes in. So what you can now also do is you can take a JSON document that adheres to that format, send a REST put call to the database. The database will take that document and essentially update all those rows in the tables that the JSON duality view resemble. And the real power here is that as part of the update, the database detects the changes made to the document and only modifies those rows or columns that actually have changed. So it's not just like a brute force thing of like, I got a new JSON document, now I update 4 tables with those rows, but it actually is capable of detecting exactly which attributes or column values you have changed, and then only execute that update for you in a fully atomic, consistent fashion. This is the same as if you were to do this relationally. So you get the power of both things here. You can get your application developers to send and retrieve JSON documents from and to the database, while the data is still stored in relational. You can also still modify that data on the relational tables directly as well. You get, again, asset transactions, full consistency, etc. So you can even have a mixed and matched mode. Furthermore, you can have multiple JSON duality views on the same underlying data to customize or match each use case of a different application. So we have said before we had a student schedule, so we would have a duality view for the student schedule. We have a teacher schedule. We will create another JSON duality view on the same underlying relational tables to represent this teacher document, where now the teacher is the root element rather than the student. And perhaps, for example, the course curriculum would also like to be able to know which courses they schedule when. You could create another JSON duality view for these. And these duality views can share or expose some of the same data, but don't have to expose all of the same data. So you have to, what I mean by that is you have the same 4 tables, but the teacher JSON duality view perhaps doesn't need to have any student information. Maybe the teacher wants to know how many students show up. You can do that. Maybe he doesn't care about the students. So you may not have to touch the student table at all because it's really not relevant for the teacher. Likewise, for the course curriculum, they may actually not need to have the full information of the teacher, just know which teacher will give this talk by the name or their ID and so forth. But if you have these multiple JSON duality views, regardless which select or get call you do and update or put call you do, the data is never duplicated, it's backed by relational tables, and hence it's always consistent. And this is much better overall for application development than JSON databases, which will eventually force you to have multiple collections and therefore multiple documents in there with repeated data. Now, some of you, I hope, also use Oracle Database for a very, very long time. Well, the good news is, as I said before with Converged Database, businesses have seen tremendous value by just upgrading an Oracle database and leverage that. So if you have an existing Oracle database where you say, hey, all our business data is in there, I would love to expose this via REST, via JSON documents, etc. How can I get this capability? Well, the answer is simple. Rather than installing a document store and then ETLing your data over into that document store, keeping it in sync, etc., all you have to do is upgrade to Oracle Database 23 AI, and you got it out of the box. It's there. It's not a cost-based option or anything like that. You just have it. You can start using it from there. That also enables you to basically add new document-centric applications now to your already existing databases. So as said, if you have an existing Oracle database, upgrade, start defining JSON duality views on your existing data, and there you go. Now you have a document-centric use case exposed to some application that may never ever know that behind the scenes there's an Oracle database. Really, really powerful. This is so powerful that I want to show you one quote of the analyst here from IDC, Carl Olofsson. Oracle's JSON relational duality, a truly revolutionary solution, is perhaps one of the most important innovations in information science in 20 years. So we're really excited about it, the analysts are really excited about it, and a lot of customers are really excited about this as well. And hopefully so are you. Let's go to the next, unification of graph and relational. Graph databases have gotten really popular lately in perhaps the last decade. They have been around for much, much longer, but they have gotten really popular for all sorts of connection detection between data points, fraud detection, upselling capabilities, and, right? Now, what we want to enable developers to be able to is to navigate the simple navigation of graph with the power of relational. So, what do? Well, we introduce new property graph views in Oracle Database 23 AI that enable developers to treat data as graph vertices and edges. So we said before, graphs are powerful ways to query connections and relationships between data or data points. Let's take an example. Let's say we want to find out an indirect money transfer from 2 bank accounts. So it's like where I give money to Chad, as I see him here, and Chad passes on that money to Billy. I want to find out whenever that is happening, because that could be maybe fraud, right? It's like I'm actually giving Billy money via an intermediary. So we call my account B, we call Billy's account E. Let's see how this would look like. Now, graphs or graph views enable treating bank account rows as graph vertices. So you have a bank account table, and you basically say each row now is a graph vertice. And then, likewise, they enable to treat money transfer between accounts as graph edges. So basically, the connections between those data points. Again, we have another table, and now we say these are actually the edges that connect those graphs together. Defining a graph property, a property graph view, is simple. It's yet another view object in the Oracle database. So again, you don't have to get a graph database that you put there and you kind of ETL your data over, etc. No, you define a property graph view where you specify your vertex table and your edge table, right? We see that a bank accounts and the bank transfer. And once you have that, you can query that object via a simple graph PGQ syntax. So this query here will find every bank transfer from account B to E. We see the IDs here, B and E in there, where we had 3 vertices, right? So you see the 1, 3 there in the PGQ syntax. And that will give you every transfer where we basically had a transfer happening over an intermediary. And find this really, really quick. Now, a quick note here. PGQ is actually part of the SQL standard. It actually came in came in the ISO SQL standard in 2023, and we as Oracle actually worked on that standard. So again, we're giving you this capability on top of an open standard rather than a proprietary language that may come with your graph database. Now, truth being told, you could always write this query in pure relational. You can today write this query in pure relational. It would look like this. It will require 12 joins and 3 unions to handle that case to get you an intermediary. So while you can do it in relational, relational wasn't really built for that. SQL is really, really powerful. You can express it as that. But the graph PGQ syntax, the property graph query syntax, is much more concise and much more powerful in its nature of expressing these queries. So I want to show you here another analyst quote of what Ron Westphal from the Future Realm group says. Now, any enterprise running Oracle database can benefit from single declarative graph navigation on all their existing business data. And that is true. If you want to start leveraging these graph queries and these property graph views, guess what? All you have to do is upgrade to Oracle Database 23 AI, your existing database, and you can start using that capability. Again, it's not an option, not a bolt-on anything. It's right there for you to use as a feature, a core feature of Oracle Database 23 AI. Now, with Oracle Database 23 AI, one part of an app can treat the data as relational, while other parts of the app or different app can treat the same data as a document, and others can treat it as a graph. It really does no longer matter. So again, this whole converged database architecture, right? You have the data in there, how you want to treat it, how you want to access it, it really doesn't matter anymore. You get the best of all of these worlds, and at the same time, a huge benefit for developers, updev, and data consistency all together. One more analyst quote here from Mark Stamer from Wikibon. And I like this one because this takes us back quite a while. I had to actually think about what he meant there. Developing new apps using a pure JSON or graph model, what he means, aka a single-purpose document store or a graph database, is now like committing to using a basic flip phone for the next 20 years. This is like, I never really had a flip phone. I guess I don't know. I know of them, but it was like, what's a flip phone? Ah, that thing. Yeah, right. Okay, makes no sense, right? You really don't have to do that. You can do it, of course, but this is what we believe in. Again, converged database architecture. All these capabilities should be available to the database that you're using. You should not have to use another database that can just offer you that one capability and therefore have to synchronize the data, ETL the data, and. Now, the last part, the really fun part. Unification of AI and databases, right? So it's like, again, there's a reason why it's now called Oracle Database 23 AI. So we all got a crash course last year on AI, and a really fast crash course, quite deep. on what all this looks like. Well, we all know AI databases are essentially called vector databases, so they allow us to store vectors in the database, right? So AI uses this data representation called a vector. Now, what is a vector, right? Well, a vector represents the semantic content of an image, document, video, etc. Really, whatever you give it, it represents that. Really what it is, a vector, on a very high-level concept, you can think of it as like a really, really, really large array where each individual entry in that array has a significant meaning. Now, you cannot really treat it as an array, but it's basically a sequence of numbers, a lot of numbers. And each of these numbers, they call them dimensions, has a meaning that the model gives that number. So, for example, if you have a model that vectorizes or embeds pictures of houses, a model that is trained on identifying and characterizing houses, you could give it a picture of a house, and then the model will create a vector for that house, where each of these numbers or dimensions represents a given attribute that that model knows, right? Like the first number is for the type of the roof, the second number is for the decoration that's being used, third number for the stories, and, right? So each dimension or number represents a different feature of the house, and that is basically where they're different from arrays. Arrays are really just lists of significant entries, right? It's like a list of phone numbers. Every phone number in itself is meaningful. In a vector, you actually need all the numbers to be meaningful, because that is what the model has classified or really generated for you. Each of these individual components it needs to make sense of the data. It's also an important aspect that you can actually only ever compare vectors that are generated by the same model. If you try to compare vectors by different models, well, the numbers are completely different, right? Meaning, have a different meaning, therefore you cannot compare them. Now, this is a very, very simplistic case here, right? It's like usually vectors have hundreds, if not thousands of dimensions, right? It's like really depends on the model and what you try to embed or vectorize, right? So, but just for the simplicity's sake, let's move on and take this vector and fold it down and just let's imagine it has only 2 dimensions, right? Because it's super easy to print. We have an x and a y-axis, right? We have only 2 dimensions, 2 numbers, and then based on that, we can put different pictures of houses on a scale or on a spectrum, right? So let's say we want to compare whether 2 houses look alike. Well, our eye will obviously tell us that the 2 houses on the screen there are in Adobe style. They look much more similar than to the house I want to call Japanese wooden architecture, right? Well, in a vector, you will get these numbers back that resemble that different information, and the numbers in those 2 Adobe houses will basically be closer together or more similar than the numbers representing the wooden house, right? And this is basically how you do this distance or similarity search. Now that we have these numbers and can get meaning out of those numbers, we can actually compare 2 vectors and see how close these numbers are together. And this is, again, the similarity search, hence why we call it semantic similarity or similarity search. So they will not be 100% identical because it's not the same house. It will only happen if you put the same house in. But they will be very similar compared to the other one. And now you can use that information to infer whether another picture of a house would be more similar to the Adobe style or to the wooden style and so forth. The same thing happens with words, right? It's like vectorization or embedding for words has been out there for many, many years. You would do the same thing. You would basically feed a word through a machine learning algorithm that embeds or vectorizes that word. You get a vector with the different data points representing different things. And if you were to put them on a scale, you will see that an elephant and a dog will be closer together than a pear or California, because elephant and dog are animals, California is a state, and pear is a fruit. So again, you can use this. The same thing with documents such as PDF, etc. It's really always the same concept. You'll take the input, you give it an embedding model or machine learning model, that will spit out a vector that represents the data of the input that you have given. And once you have that vector, you can compare it with other vectors. However, that is all cool, right? It's like, so you can figure out whether 2 words or 2 pictures are close to each other. But actually, to answer business questions requires business data, right? And Oracle database happens to be the leading repository of business data, right? It's like the Fortune 500 all use Oracle database for the most mission-critical data that they have that they manage or that they have in their estate. Now, let's imagine if we stay with this concept of houses, right? There is some end-user data, right? It's like perhaps buying history of your customer, which houses has he bought or sold. interests, balances, locations, and so forth. And then there's product data, right? It's like basically what houses are available for sale, et cetera, what's the configuration, and so forth. So let's look at a quick example. Let's imagine we are building an app that allows us to house hunt. So a mobile phone app where you can upload a picture of a house, and basically the app will tell you, hey, look, here's houses for sale that look like this, houses that you may want to look at and maybe buy. Well, finding a good match requires combining the semantic picture search, the picture itself, with searches on business data, right? Including the customer data, such as where do I want this house to be? Well, probably where you're living now, in the vicinity, right? Or some preferred location that you've given. And how much am I willing to actually spend to buy a house? Because there's a lot of nice houses out there, but you will probably not want to spend an unlimited amount of money to buy that. Same with product data, right? It's like what houses are available, sale by location, what is their price? You really need to combine this to actually give a meaningful answer back to the user rather than just saying, oh yeah, you uploaded a house, here's like 10,000 houses around the world that look all the same, right? Now, searches on a combination of business and semantic data are more efficient if both types of the data are stored together. Now, obviously, you don't want to kind of have to, have the business data on one side and the vector data on another side. So vector databases will say, hey, this is no problem, right? You just give us all your business data, and we vectorize that in our vector database, and you can do these queries, right? So now you have the picture vectors in there, and you have the business data in there. Now you can just use vector searches in our technology. However, you actually have to continuously send the business data to those vector databases, because guess what? I may actually say, hey, instead of spending a certain amount of money, I'm willing to spend a bit more. Well, now I update the preference. Well, that update needs to go over. Or perhaps I say, hey, you know what? I actually don't need that house that desperately, so I'm willing to spend less, right? It's like you need to send that to the vector database to give me still meaningful answers, because now I don't want to see a house that I no longer can afford or don't want to buy or don't want to afford, right? And the other thing is that the business relevant for the question varies really widely. So it's one thing to send the business data over to buy a house. Completely different data is required when, for example, offering where to go on vacation. Now, all of a sudden, my home location may not matter so much anymore. What I'm willing to pay on vacation may be completely different than what I'm willing to pay in a house, and so forth. So you actually end up to send a lot of business data over to these AI vector databases, because you cannot predict what questions the users will ask. Hence, you kind of need to send all the data over for whatever questions there may come along. Now, here's an interesting thought. Vector databases are really, really, really good in vector search. Clearly, they are purpose-built for that, right? But they're actually not so good in searching and securing business data, right? Structured data. Most of them are really not good in securing business data. But now you just send all your business data over there. Now it's available there as vectors. Yeah, looks cryptic to us, but not to machines, right? So an interesting thought. Maybe not the best solution. We think actually the best solution is to add vector search to your business data, right? Again, converged database architecture. That allows you to use both business data and vectors when answering questions. No need to synchronize the data, ETL it over, etc. And hence why we have introduced AI vector search in Oracle Database 23 AI. So, unification of AI and database, right? It allows you to use vector search to find similar unstructured data combined with the power of a relational search on business data. So what does this look like? Well, for those of you who have been in the MySQL keynote, guess what? We also have a vector data type, right? All of these databases have now a new data type called vector, right? So if you wanted to actually vectorize such a house image, you would create a new column of type vector. You can specify some parameters if you wanted to, how many dimensions you want this to accommodate and so forth, or you could just say vector, right? And then once you have that, you can vectorize with your large language model or embedding model those pictures of your houses and store the vectors in the database. So far, so good, right? Here's the fun part, right? We have said, okay, similarity search is all about comparing two vectors from the same model and see how close those digits are, right? Those so-called dimensions, right? That's just gotten really simple. There's a new function called vector distance where you say, hey, if I want to see how close a house is, or a picture of a house is, to all the houses available for sale in this house for sale table, you're going to use vector distance, parentheses, that new column of type vector that holds the vector for all the houses for sale, right? And, for example, a bind variable with that input vector from the picture you just uploaded. And because it's a similarity search and you search where it's closest and not exactly the same, right? Because only the actual same picture will produce the same vector. You do it order by, and then fetch first 10 approximate rows, for example. And that will give you the 10 houses most similar to the vector that you have provided. That's it. You just did vector search. And remember how I said before, we believe adding SQL statements, not another database, to accomplish these capabilities. No ML expertise is required. All your developers, your IT guys, every tool that can speak SQL can all of a sudden now do AI vector search. And that is really, really powerful. But we said vector search is one thing. Business data is what's really relevant, right? To answer the question in context to what the user actually wants. So, what do we do next? Well, we have a SQL statement. Guess what? To add the business data, we add a join, a subquery, what have you, right? A where clause where we now say it's the same vector distance search, right? Nothing changed there. We just added a where clause where we say where the price is less equal to the budget of the customer and the city is in the search cities of the customer of choice. That's it. So now we find all houses that are similar to this picture on the slide that match the customer's preferred city and budget. And that statement combines customer data, relational, product data, relational, and AI search, vector search, in 5 lines of SQL, right? In a single integrated solution, and all data is always fully consistent. And that is the true power. And guess what? All you have to do to get to the capability is, somebody? Upgrade to Oracle Database 23 AI. Exactly, right? Now, there's of course a little bit more to that, right? So it's like Oracle Database accelerates AI vector search using sophisticated vector indexes. So we have new indexes as well, or indices, right, that are kept in memory to actually help you traverse these vectors really, really, really fast, right? Guess what? Converged database. Oracle can partition these vector indexes, like we can partition any indices or any table in the Oracle database since ever we introduced partitioning. So all of a sudden, you can partition your house vector by, for example, city, and now you have local vector indexes by city. And now you no longer need to search through all the other cities that are actually not relevant to the query because we partition prune and you only search the one local index on the one local partition. And now your query can get 1,000 times and more faster just because of that simple trick, right? Really, really powerful. Guess what? Oracle transparently scales vector processing across computers in a rack cluster. If you have rack, it will scale across the rack cluster, of course. Data is fully consistent. No worries there. Well, but what about if you actually have your production database and you say, hey, I don't want to scale my vector search across my rack cluster, every node, right? It's like, I also want to serve my customers in my OLTP scenario. Well, guess what? Oracle vector processing can be isolated to a subset of rack nodes, right? So that you don't avoid the actual intraday OLTP workload. So you can say rack node 1 and 2, no vector processing happens there. It only happens on rack node 3, right? And 1 and 2 remains open for business as usual, as it has been for all these years. And of course, if you happen to have an Exadata engineered system, well, guess what? Oracle Vector Search can be transparently offloaded to the smart storage cells, right? So you can query push down the vector search onto Exadata storage cells as well. You can shard vector processing with Oracle's global distributed database, our sharding capabilities in Oracle database, right? So like for geographic distributed database, for example, so that your vectors from Germany stay in Germany and your vectors in the US remain in the US, or if you like the vectors in New York, stay in New York, and the vectors from the Bay Area folks like me stay over there, right? Whatever you want. Works out of the box seamlessly, right? No need to do anything else. And of course, AI vector search also benefits for all the other core functionality and capabilities that we have in Oracle database, whether it's parallel query processing, transactions if you want them, analytics, disaster recovery, security, and so forth. You name it. It's all there. Now, adding semantic search to relational search is great, but we can do even better by adding generative AI. So what does that look like, right? So vector search is cool, plus generative AI. That actually enables end users to ask simple questions with natural language, aka speak to the machine kind of thing, right? The AI vector search can map the natural language question to relevant data in the database, and then the user question plus the relevant data can then be passed to generative AI to provide an informant answer to the question. So let's look what this looks like. We'll take a look what this looks like. Now think of generative AI as a smart college graduate, right? It's like, A person that came out of college, knows the subjects at hand really, really, really well because just studied it, came out of college, right? But now imagine that smart college hire to answer your company's support calls on day one. Well, they have a lot of general knowledge that they learned at the college, but they really don't have any knowledge about your products and the history of your products, right? So actually answering support calls on day one is maybe a little bit unfair to them, right? So Gen AI, think of this as the smart college student, right, or as college grad, right? Left on their own, the grad cannot give good answers to product support questions. Same as if you just use generative AI model without your business data, it cannot really give good answers to your support center, to your customers, etc., right? It's like it can only provide what it has been trained on, which was not your business data or your private data. Now, what if the grad could be instantly augmented with product and product support information? Then they could give better answers, right? If you can tell them, hey, here's our product history, learn this within a heartbeat, well, obviously now they can give really, really smart answers to these support calls. And that is where vector databases come in. Now, vector databases augment generative AI by retrieving detailed, often private content, your business data, that is needed to answer a question, that is needed to give a meaningful answer, right? That's usually called, or that is called retrieval augmented generation, or often abbreviated as RAG, right? So how does this look like? Well, the user sends in a question, encoded as a vector, and sends it to the vector database, right? So it's like the question, the natural language will be vectorized by a model, will be sent to the vector database, right? The vector database finds the private content, for example, documents and so forth, that closely match the user's question, because we now have access to that information, to the business data. The content is then sent to Gen AI to help answer the user's question. So the Gen AI model gets the general question plus the business data, and now it can formulate an answer that is actually meaningful to the user because it has this general knowledge plus the business data. And that's really, really where the power lies in that. Using a similar process, Gen AI can be used by developers to generate SQL queries, JSON duality views, graph views. You can now actually talk to an Oracle database, and we call this capability Select AI if you want to see it. Google Oracle Select AI. You can actually write in plain English, give me all my sales from this country, blah, blah, blah. Send it off. We send it to generative AI. It will construct and run the SQL query for you. So development all of a sudden, or even like you as a business user getting questions out of your database has gotten a lot simpler. It can happen on documents and rows and graph, all one converged database. This will revolutionize application development, right? There will no longer be the need for writing pages and pages of code. We will see more and more AI being used to get to answers quicker, to build applications quicker. That will probably not go away. But developers will be more productive than ever before thanks to the innovations in Oracle Database 23 AI. So, to finish up, key takeaways. Oracle is introducing a revolutionary converged database technologies that unify relational, JSON, graph, and AI vectors on a fundamental level. They are not just bolt-ons or anything you have just seen, on a fundamental level. SQL query capabilities, predicate pushdown to Exadata, etc., etc. It eliminates the simplicity versus power trade-offs debate that we had, right? It's like, well, JSON is really easy, but now I have data inconsistency issues, but relational will be really powerful, but it's, I have to always do this ORM mapping, and it enables unprecedented productivity for application development. Data, AI, and UpDev are rapidly transforming. We encourage you to embrace the changes to reap the rewards. Thank you very much for your time, and I hope you have a good rest of Oracle Dev Live here in New York. Thanks.